All right, so here's our example for 6.3. So it says, given that segments AC and BD bisect each other, we need to prove that segment AB is parallel to segment CD and that segment BC is parallel to segment AD. So again, if you look at this picture, right, this ABCD is supposed to be a parallelogram. That's exactly what this says, right? This says that parallelogram ABCD would exist. Okay, and this up here, this is the fact that the bisects or the diagonals bisect each other. So what this really is trying to prove that from knowing if the diagonals bisect each other, can you prove that something's a parallelogram? So I know that the diagonals, there we go. I know the diagonals bisect each other. So is it a parallelogram? So let's talk about a couple things. So if AC and BD bisect each other, that means AC is broken into two congruent segments because bisect means splits into two congruent parts. I also know that BD is broken into two congruent parts. Okay. And now AB and CD. So AB is here and CD is here. So to prove those two lines parallel, I have to use these two triangles. These are still going to be triangle proofs here. So I have a side, I have a side. I need a third piece of information to prove that these two triangles are congruent. Because if these two triangles are congruent, I think I can prove the lines parallel using an angle pair, right? Well, the third thing is going to be right here at E. These are vertical angles. So these two angles will be congruent. There's my angle pair, and I'll be able to prove these two triangles congruent by side angle side. That's this triangle and this triangle. Okay, so let's go ahead and try to put that in our proof, and then we'll talk about what we have to do after that. Okay, so it's going to go away. All right, so here we go. So because AC is being bisected, I know that segment AE and CE are congruent, and that's because of a segment bisector. Segment bisector divides a segment into two congruent segments. Oh, I picked the wrong one. AE and CE. Sorry. That's better. BD is also bisected, so let's choose BE and DE. I'll try to do it right the first time this time, huh? BE and DE. There we go. And again, same idea, segment bisector. Great. And now I use these two vertical angles, so BEA, angle BEA, and then this angle, and I'll go in corresponding order, so BDEC. DEC are going to be congruent, and that is because they are vertical angles, and vertical angles are congruent. Nice. And now you can see my two triangles are drawn side, angle, side. So triangle. And again, I'll use the same ordering here. BEA will be congruent to triangle DEC, and that's by side, angle, side. Okay, great. So why is that helpful? Well, again, let's go ahead and label the parallel lines AB and CD. AB, CD. What is a transversal between them? How about we choose BD? Do you see this letter, right? It's like a Z, it's an N. This is that alternate interior angles situation. So these two angles will be congruent, not because they're alternate interior angles, but because they are corresponding parts of these two congruent triangles, and they're congruent. CPCTC, ABE, CDE. Angle ABE is congruent to angle CDE. And that is because of CPCTC. And now I have shown that there is a pair of alternate interior angles. Again, I'll draw them one more time. I have shown that these two alternate interior angles are congruent. And since alternate interior angles are congruent, then the lines are parallel. So again, it's that converse thinking, that order thinking. Okay. So again, we're going to say that the two lines are parallel, and it's the first two, A, B, and C, D. And again, if two lines cut by a transversal form congruent alternate interior angles, then the lines are parallel. Great. So now we have to do a similar proof for the second part, okay? Now we already have these sides congruent, but the new sides to prove parallel are BC and AD. Well, BC is at the top, and AD is at the bottom. So now we have to use, again, side and this side, but now we have to use this pair of vertical angles, BEC and DEA. BEC and DEA. So angle BEC is congruent to angle DEA. They are vertical angles. So then these two triangles, again, same lettering, BEC and DEA are congruent. BEC. Okay. And that's again by side angle side. So now if I take a look at the picture, so now I still want to try to prove that BC and AD are parallel. Let's go ahead and make the actual Z. So you see the Z, right? Inside the Z, these angles will be congruent. That's going to be this angle up here and this angle down here. That would be BCE and DAE. They're going to be congruent because they're corresponding parts of congruent triangles. BCE, DAE. Angle BCE is congruent to angle DAE. And that is because of CPCTC. And now, since those two angles are congruent, and they are alternate interior angles, BC and AD are parallel. If two lines are cut, alternate interior angles congruent, lines are parallel. Boom. And there's my second. So this proof is just long because you have to do the same thing twice. Sorry. Okay, that's why I did it with you. Hopefully you can do it by yourself. Submit that answer. Get that big green check mark. Love it. All right, good luck on this homework.